Okay, ladies, gentlemen, everyone, good to see you. Welcome to another week of EECS 440. We are right in the middle of your P1 milestone, and it's a really, really nice thing to see so many Unreal Engine editors open, building that kind of virtual lab. A reminder, right? The lab, right, as you build it, the aesthetics are very important, the sound, the visuals, but I think what's really going to be interesting to you, and what a lot of courses I think don't teach very well, are those interactions. Those interactions that you're going to build that make a space feel like an actual space, a place you can do things. You can actually not just look at the lights, you can turn them off and on. You can use the devices you see, copiers, printers, the whiteboards, stuff like that. I think that's where you're going to kind of get your confidence up, really up on Unreal Engine. And as a result, what we're going to do today is we're going to spend quite a bit of time talking about the nature of programming in Unreal Engine. So hopefully, as you kind of get into some of our more difficult programming tasks of this project, you will have a bit of an easier time after our lecture today. Just looking at the schedule, on Wednesday, you have your P1 milestone tasks due. A reminder, what does that mean? Well, that means we want to see some sort of at least draft implementation of all of those P1 milestone tasks on your spreadsheet. I think those are the white ones, okay? I'm not sure though. Is it the white ones? Someone tell me? Yeah. So the red ones I think are P1 Alpha, and then you're going to have just a couple more for P1 Gold in a couple weeks. And so you don't have to have all of those tasks completely finished or bug-free or perfectly to spec. You just need to have a non-trivial implementation of those tasks, and you'll get all the points, okay? So don't spend too much time perfecting everything. If you're banging your head against a task, move on, and that will help you retain some sanity, okay? And you'll be able to return to those tasks later for P1 Gold when you have even more knowledge with Unreal Engine, and you should just be able to knock them down pretty easily, okay? All right, a couple announcements. One, I think when I was recording the workshop, the bit rate that we used with OBS was a little bit low, and so it's a little bit fuzzy if you're watching the footage from our previous lecture where we implemented a lot of good stuff for P1. We have lectures from previous semesters that are pretty much the same lectures on YouTube. I posted one of them in the Discord server, and those are crystal clear. They were recorded on this computer rather than this one. So in the future, if we do record anything on this one, I will bump up the quality settings, and we'll see if that fixes the problem. Another reminder as well, on Wednesday at 8 p.m., we will have our first film session. Okay? Film sessions, if you recall, we get together, we talk a little bit about a film, its depiction of XR, the historical context around which it was created, and then we watch the film. If you're there in person, that's the end of the story. You get the points just like that. If you're not there in person, you need to watch the film yourself, which means you're going to be writing a very short essay, and you're going to be snapping some selfies as well. So probably a little bit more fun to just kind of show up at 8 p.m. if you can. It says Dow 1017 on the schedule. I'm not sure if that's where we're going to be. That's what I'm going to try and get. But when Wednesday comes, I'll make some announcements if we need to update the room. Okay? Okay. I have some extra credit for you if you're interested. There is an IGDA Ann Arbor event coming up on Thursday. So it's going to be Sean Pride of Warner Brothers Games. And you see the big Spartan logo here because he's also of the Michigan State University Game Dev program. They have a very nice program over there, very good option for grad school, especially if you can get that in-state tuition. And he's going to be talking to us about how kind of what the philosophy at Warner Brothers is over NPCs. And how kind of traditional game AI can work and how they do it at Warner Brothers. So could be an interesting event if you want to. And if you do attend, you'll get a little bit of extra credit for doing so. How are you feeling with Unreal Engine and Unity thus far? I'm curious. You've had about 2 weeks in Unity and about 3 weeks in Unreal Engine. And that is not a lot of time for game engines. You're moving pretty fast. Are you starting to see similarities between them? The way you do things, the way that certain UI elements look, the way that you tackle certain problems, right? Again, all these game engines are pretty much the same. The main thing that's different between them is a little bit of UI shenanigans and some naming conventions that are a bit different. Today, we're going to discover that blueprint kind of visual scripting, visual programming is every bit as powerful and featureful as some of the textual programming languages you already know. Things like Python, C++, stuff like that. A lot of the features you use in those languages are there in blueprints. They just look a little bit different, which might slow you down at first, okay? I really like this video right here, Welcome to 3D Software. As students are going through learning Blender, learning Unity, Unreal Engine, we tend to run into a lot of common things, a lot of common problems. Savannah XYZ is a recent 3D art student herself, and a very prolific one. So let's take a look at what she thinks about 3D software.
Welcome to 3D Software. Please enjoy your stay. There's so many things to do, so please let's not delay. Got limitless features, most good and some weird, and lots of little quirky bugs that we've engineered. Welcome to 3D Software. Load up and take a chance. You can make some space or porno, watch her do the Fortnite dance. Apologies is abysmal. It's not optimized. Throw it up on Twitter and we'll call it skies. Welcome to 3D Software, you'll never feel alone. Take that shit from Warhammer and make the humans blown. Unity, Unreal, which one do we choose? Just click on the tutorial and test the views. Welcome to 3D Software, sure to save your file, recreate your childhood vectors, write scripts and compile, beat timelines and layers, you tweak the scripts, none of the features that you've all requested. Welcome to 3D Software, we know that it's slow, but shut up watch a 12-part series on making bread dough. This is super, brings me to cool up with time. Okay, this is a white god of wine. Beginning game is in a sweater for a frog. Take a short starring Master Chief for bonus game your dog. EECS has no different 3D printers, plus a pair of better shadows for some dough. Medieval weapons recreating the pursuit. Could I get to see you in rendering all of the time? A little bit of rendering all of the time. Descriptions are a tragedy and fantasies a crime. Compiling and rendering all of the time. Could I get to see you in rendering all of the time? A little bit of rendering all of the time. Descriptions are a tragedy and fantasies a crime. Compiling and rendering all of the time.
So one of the reasons I like to show this video is that it's also a good example of a theory that I have started to develop. These days, so Savannah XYZ is not a very old channel. It is very new, this particular YouTuber, and yet it is very successful. Some of her songs, just only 2.3 million views, no big deal, right? Not too bad. There are a lot of very good 3D modelers out there. There are a lot of very good programmers out there. There are a lot of very good musicians and singers out there, but there are very few people who are excellent 3D modelers and musicians and singers / voice actors. So Savannah is a very good example of someone who is rare because they have mastered not one particular skill, but several, and are able to bring those three things together to create stuff that actually no one else can do. And so when, especially in my EECS 298 course, which is all about, so it's the 3D technical art course, which means we're going to learn art, we're going to learn technology. We learn Blender for art, we learn Unity to make those characters and environments come to life. You really do these days, if you want to stand out, you do need to become a multidisciplinary person. It's at the edges of the Venn diagram where there's that little sliver of people, right? Where there are still discoveries to be made and problems to be solved that can only be solved by people with both of those abilities right in the middle, okay? So anyway, a very cool channel. She started off doing tutorials on 3D art, and they were kind of fun, but then she quickly moved into combining music very heavily and singing very heavily into her animations, and that's when her channel actually exploded, okay? Wall Street Journal says that we are seeing an uptick, even these days, in VR being used by very surprising companies, UPS, Volvo, Walmart, and a lot of this is for employee training, right? You've got people entering into situations, doing kind of a role play on how to deal with angry customers. In this particular example, you've got a financial services company that is trying to train their financial advisors on how to deal with potentially, angry or frustrated clients, or clients with particular questions or particular habits, stuff like that. So you can go ahead and read this article if you're interested, but this is the kind of thing we've been seeing in many cases. It's not the big metaverse, moonshots that are taking off with XR. They're all the kind of tinier, less sexy, but very important niche use cases for XR that are actually kind of finding a groove and making it happen. Okay, your P1 Alpha will release on Wednesday. Don't forget about that. Your first film session will be on Wednesday. If you finish up in this course, you're doing work, you're working hard, and then you go home, make sure that you wrap up and clean up your headsets. You want them to look about like this, okay? Get the cord at least off the table. Doesn't need to be perfect, okay? It's very easy for them to get tangled. What you really don't want is something like this little loop where it's hanging off the side, and you don't want something like this where the cable's actually on the ground. Why? When the cable's on the ground, it's much easier for people to accidentally step on it, which damages the cable. Or worse, you see that right there? Very common. for people in their rolling chairs to roll over repeatedly a section of the cable. You end up cutting the cable, and then the whole headset is pretty much worthless. These are multi-grand headsets, and the lab here is well resourced, but it's not that well resourced. So we got to be careful. Okay, so please be careful and take care of this equipment. And if you do, the space will remain available to you. Okay, we do not want to get kicked out of this space. That would be very hard to develop XR stuff without this space, okay? This course really couldn't exist without this space. Everything would be way too theoretical. I want to show you a fairly proud, fairly long-lived XR company that is local to Ann Arbor. It is engineered. I mean, the entire engineering team, last time I checked, is former 440, 494, and Wolverine Soft students. It is Spellbound AR, and I think this is a company I showed you on the first day, wasn't it? This is a company that is all about kind of immersing people in the context of pediatric medical care. So you've got kids coming into a hospital. They've got scary procedure coming up. How do you calm them down? Maybe the kid has had a surgery and you need them to get up and moving and rehabilitate, but it hurts. It's very painful. You're sore, okay? And so how do you get kids up and walking around and excited to do that? Things like scavenger hunts, augmented games that kind of coax the kids into running around, stuff like that apparently works very well. You remember that magic, right? You're a kid and anything like this just seems like the coolest thing, right? And so this is a company that actually works with, I think they work with University of Michigan Hospital. I think they worked with Stanford Hospital. Our story, maybe we can get some information about that a little bit more. Spellbound Now. Who are your partners? That's what I'm curious about. They used to have a partners kind of page on here. Who are they working with? Partnerships. Okay. Hello. Technology partners. Blah, blah, blah. Cost-effective, Vibe, Get Well. No, let's go up here. Foundations and charities. Anyone up here? No. Okay. I think I found some videos on their webpage. Yeah, let's take a look at this. So watch this AR painting game bring a waiting room to life. Let's see how it looks.
We built this painting experience to give kids a way to express themselves, especially at a time where they might not feel like they have much control over their lives.
I was painting rainbow cascade that sticker. I think it's really fun to use. They have tons of stickers and a lot of different colors. And this is my favorite thing.
Yeah, pretty adorable. Pretty cool stuff. So this is the kind of thing that the team does. They create different mini games. They try and address a lot of different pain points in kind of the healthcare experience for kids. And so it's I think not too long ago we had that question of like, is there anything else in like medical situations to distract kids, right? Well, when you go to the dentist, you have that TV up top. I think when I used to go to the hospital, they often had little toy games you could play, like a basket. They were always terrible, but the point is to burn time, not to give you a great time. Anyway, this kind of thing can go a little bit beyond that and can actually get people kind of walking around and doing different things you might want them to do. And so, the team works with medical professionals, doctors, and stuff like that, so that a doctor could actually prescribe that a patient should get out of their bed and go collect, 5 different Pokemon or something like that. So pretty cool stuff. Cool company. I don't think they're growing a ton, but they've kind of maintained a small startup size for quite a while and taken care of a lot of students, done a lot of internships and stuff like that. I think their engineering team is 3 or 4 people maybe. So not huge, but still pretty cool. And they are local. So pretty neat stuff. It was very fun to walk downtown and hang out with them and then see some familiar faces, some old students of mine. So anyway, all right, a pretty cool company. Okay, so does anyone have any questions or comments about Project One? Okay, all right. So we got a bunch of grades back to you recently. Please check them out and reach out if there are any problems. And in the meantime, what I want to do is I want to talk about a little bit of a spicy topic. I want to talk about programming in Unreal Engine. This is something that you either appreciate usually or you are quite annoyed with in many cases because it's so different than what you might be used to. Does anyone know what this is over here on the left? So I just went through this, and my situation doesn't look too much better than this, actually. Yes?
Inside of a PC. Is that all power brick is?
Yeah, this is the inside of a PC. This looks like a PC build that maybe didn't go quite the way that the owner intended. I mean, this is about what it looks like for me building my recent PC. It was a big mess. I wasn't able to manage my cables. There were lines and shapes and colors everywhere, and following the logic of it all was a very slow thing, very nasty. Here on the right, do you know what this is? Anyone? I don't know if we have any electrical infrastructure this nasty in the States, but I've seen some pretty nasty stuff in the States. I don't remember where this one is from. I think some places in Southeast Asia. But this is electrical infrastructure that has become very messy over time as more and more things got plugged in and more juice needed to flow. This looks kind of similar. This is spaghetti code that you might see if you create a very gigantic blueprint or a very gigantic blueprint component. Your event graph here in Unreal is so full of connections, it looks like a spaghetti a meatball right here, okay? Very nasty. It turns out, though, it can look much cleaner and much nicer. And the way that you build a logic in most game engines, you want to kind of keep your logic small, encapsulated, reusable. You want to create components that only do what you need them to do and nothing more. That keeps them small, keeps them from turning into a hairball. Okay, this can be beautiful. This kind of visual programming that Unreal is so famous for isn't just an Unreal thing. If you've used stuff like MIT Scratch before, it might look kind of similar. If you have ever used any tools like Yarn or Twine, right, dialogue or story editing tools, this is the dialogue from my indie game, my horror indie game, Greek Tragedy. And this is the tool that I used to build it. You can see it branches, there's logic inside of it, it's good stuff. Unreal Engine is a very famous engine. I think many people would call it the #1 engine right now in the industry, not necessarily for the number of games that use it, but for the prominence of those games. Fortnite, a game that you've probably heard of, uses Unreal Engine. The makers of Unreal Engine, Epic Games in North Carolina, they actually make games. They are simultaneously a game engine studio and a game studio. So they dog food their engine all the time. They are constantly adding new features to it, and they're constantly using it in their own games. And so it is very prominent. Has anyone heard of games like BioShock Infinite? Right? also uses Unreal Engine. A lot of big, beautiful AAA video games, the biggest productions on the planet, many of them use Unreal Engine, and they get a lot out of it. But Unreal Engine is also used sometimes for big virtual reality titles. You can kind of tell that the more realistic you want your title to be, the more likely you are to choose Unreal Engine. Unreal is famous for its fantastic lighting, its realistic graphics, and in some cases, its performance and speed. But you can also use Unreal for smaller indie games, cartoony games, games with weird and diverse, interesting art styles. It's also, a good fit for Unreal. So it is an engine that can really do it all. A quick note. You've heard of blueprint visual scripting. You've seen this before in your assignments, but did you know that Unreal Engine itself is programmed in C++, and that you can also create blueprints and components in C++? Did you know that? So, Unreal Engine. If this were only an Unreal Engine class, we'd probably go into Unreal C++, but it's a really interesting kind of dialect of C++. It doesn't, the standard data types like vector and string, std string in C++, you don't use those in Unreal, okay? All the standard libraries and the algorithms that you've learned in EECS 281, Unreal Engine doesn't work with them. And so Unreal provides its own containers, and it does this because of mostly historical reasons. Unreal Engine was, I think, becoming very big in like the 90s, okay, maybe late 80s, 90s. And I think the standard library that you're used to today, vector, std string, right? It was actually very much in its infancy when Unreal Engine was getting started. As a result, Epic didn't want to use standard library and all those data types because they weren't very fast, they weren't very performant, they're kind of buggy, not very useful. And so Epic created a bunch of their own data types, and you have to use those instead, or things will just start to break. Unreal is also full of macros and full of conventions. You have to be very careful with what you call your functions. It is also managed C++. So kind of like Java or C# or Python, you don't have to worry too much about memory management. It will kind of take care of a lot of that for you. In other words, a lot of people kind of don't even call this C++. They call it Unreal++. And so it is a unique, strange version of C++. So getting it to build and run is also a bit weird. When it comes to blueprint visual scripting, you get very fast iteration. You can compile quickly, you can run the game immediately. That is iterative, it's exactly what we want. But in Unreal, if you make changes to the C++, you have to compile stuff, and it takes quite a while. It can take like 30 seconds. And it's even worse if you have an error. In blueprints, if you have an exception or a bug or an error, you just kind of get a red error message. It's no big deal. The game keeps running. If you have an exception or an error and you're writing Unreal C++ instead of blueprints, you get a full editor crash, in my experience. The full Unreal editor will crash and you'll have to open it up again from scratch, right? Unreal can take a few minutes to open. So that's super slow iteration, not super fun. In the blueprint side of things, we get much, much faster education. You can get a feel for how the engine works with blueprints pretty quickly. But with Unreal C++, there are just a ton of things that can trip you up and slow you down. And kind of, this is all to say, when it comes to both of these choices, blueprints are going to be the winner for most of us in this class. Blueprints are what we have time to teach. And remember, you're going to have to learn Unity and C# as well later in the course. But if you really want to get deeper into the Unreal, C++ side of things, you can do that. And I would encourage you to go to this lecture and watch some of these videos I linked, because it turns out the Unreal C++ side of things and the Blueprint side of things, they're very cooperative. On big projects, AAA projects, what you usually do is you write Unreal C++ to create new functions and new nodes and new component types that you then use in blueprints. In other words, you have the engineers working in C++ and the game designers working in blueprints. Sometimes, even the engineers will create a new feature or technology in blueprints, and then once it's working, they will translate it to the C++ side of things to get like a 10x performance improvement. Okay? In this class, performance is usually not a big bottleneck for us, so the slower blueprints are just fine for us. So why visual scripting? Like, what's the point of it? Because you're going to be jumping between textual C# programming and visual blueprint scripting in this course. So what's exactly the point? Why do we even bother with it? Why do we have it? Well, I went on to Reddit, and I found you'll find no end of Reddit discussions and posts debating, should I learn Unity? Should I learn Unreal Engine? Should I learn Blueprint? Should I learn C++? And I saw this message right here. I have no real code knowledge, but come from an art background. So it's Unreal for me because of blueprints. I think it's the more friendly of the two. And that is an extremely common idea. When non-programmers look at this code, they don't see these nice functions the way we do. They don't recognize what a class is, or what variables are, or what a vector 3 even is. That's like some weird mathy thing, right? What they see is literally the matrix, all right? It is blinding to most artists to look at this. There isn't that much here, but every word is strange and has no meaning to the artist. It clearly means something, but they don't know what it is. Okay, before you took like East 280, did you have any idea what void meant? Void is like a fancy sci-fi word you hear like in Star Trek sometimes, right? It's very kind of scary if you don't know what these mean. And most of these in here, you have no idea what they mean. Anyway, so it's very intimidating. This looks like the Matrix, whereas this looks like Lego, all right? And it's much, 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 much more approachable to people from an art program background. Okay? If you rearrange these Legos over here on the right, this visual scripting, you can see that pretty much literally it's the same thing. Our white line of execution here, usually in blueprints by convention, goes kind of off to the right, but we can make it go down if we want to, at which point you'll see we've got that lifecycle start function, that lifecycle update function, and the functions below it that actually do the thing. All right? And a variable way up top being stored. It is pretty much the same thing. It just looks a bit different. And so here, with the textual programming, relationships require more knowledge to actually see. You have to look around at more places. There's no line to follow. Here, the relationships are much more obvious. If you wonder what target is, well, you just have to follow the line backward to figure out where it's coming from and how it's being gotten. Okay? If you want to follow the control flow of some logic, you just have to follow this white line wherever it leads you. And that's it. Over here, with the textual programming language, it's very, very possible to write syntax errors. Everyone remembers the classic, missing semicolon compile error from EECS 280 or EECS 183, right? Where you're trying to compile and the compile message is awful, and so you lose hours to a missing semicolon. Here, right, any typo leads to scary errors that you don't understand. Especially, you're going to get a lot of those if you don't have code completion working. And if someone doesn't know what's going on in this code, they can't read this code, they're not gonna get code completion working unless it works just out of the box, which it often does not. Okay? Over here, it is actually impossible to mistype something. If you mistype something, it just doesn't show up in the search box. okay? And so once you actually hit enter, you find the thing that looks about like what you want, it turns into a node. You can't actually mistype something, and that's a big deal. Over here, right, programming is very terrifying. I can't do it. Over here, it's not programming, it's blueprints, it's Legos, okay? It's also a confidence thing. This, okay, no one thinks of this when they think of programming. As a result, people are more willing to give it a chance than this stuff over here, which looks like the horrifying, scary programming that, people have heard about in the films and movies and stuff, okay? Here's an anecdote from one of my friends at Azure Ravens Entertainment. This is Corbin Reeves. He teaches at U of M now, and he taught at Lawrence Tech. He taught at Eastern Michigan University, Kettering University, a lot of places. He runs an outsourcing studio in Saline. He said, we'll prefer, generally, our team will use Unreal Engine over Unity, and it's for this reason. Our team is very artist-heavy. We only have like one programmer or so, and so the blueprints are extremely important because the artists actually have the confidence to get in there and make some code and do some tweaks themselves. And that's a really, really, really big deal. But here's the thing. A lot of people don't believe that blueprint scripting is programming. In fact, that's why they love blueprint scripting. It's not programming. I want to assure you it is every bit the programming that you might be used to with C++, C, Python, and stuff like that, C#, Java. It is standard programming, and I'm going to prove it to you during this lecture, okay? Variables. Let's talk a little bit about variables, right? One of the most important elements of the programming that we just tend to do. Variables are not written like at the top of a file. I mean, they're not even in the top of a file. In your blueprint editor, your event graph, when you see all those nodes hanging out there, you're going to find all your variables stored off to the left, not even at the top, but to the left. And you'll see that a lot of them, have names, but they also have all the features you would expect. You can have a variable of a bunch of built-in types, like float, string, Boolean. All of these are provided by Epic Games themselves. They just assume you're going to need them. One of the most useful is actor. Actor is a type that describes any of the objects that are just kind of littered around your scene, your map. It could be a chair, it could be a block, it could be an invisible actor, it could be anything. It could be the player. But you can create that if you want to. Another really interesting thing, useful thing, is that you can create your own data types as well. In the same way that in C++, you can create a class, or in C# you can create a class, and then that class becomes available as a new variable type, a new data type. You can do the exact same thing here. Here, we've created kind of a goofy data type, a goofy blueprint called Big Biscuit, and as a result, we have a variable called biscuit preference of type Big Biscuit. What's also really interesting is that in exactly the way you'd expect, you can have an integer or maybe an array of integers or a list of integers or a map of integers or a single integer. You can also decide whether you want to have a single version of that variable or if that variable is actually a container of variables. Like this isn't just a string like this one. This is an array of strings. This, I think, is a map of actors, or sorry, a set of actors. A really quick question. Difference between a set and an array. It's a good interview question. It's a bit of trivia. I really like sets a lot because they help eliminate a certain type of bug. Yes?
Sets have like...
Bingo. Sets do not allow duplicates. Okay? Lists and arrays can have duplicates, which can possibly be quite a big problem. But sets do not allow duplicates. Okay? All right. You can, as we see here, right, you can create all sorts of variables. You can create a variable called favorite foods and have it be of type string. So you can have many different foods that are your favorite. you can go in and you can kind of choose what type of container you want this to be, a single, a map, a set, an array. You can do all sorts of stuff. You can make your variables private. By default, they are public. And that's kind of a strange thing, I guess. In most languages, when you create a variable, it's considered private. Here, when we create a variable, it's considered public, unless you mark it as private. And down here, you can even give your variables a default value, which is kind of cool, right? These variables can be made inspector editable if you click this little eyeball. This is a really important thing to do in many cases. It's right here. That's why the eyeball is placed so near the type. When you click this eyeball, what's going to happen is that this component you see in the details pane is going to have that variable be present in the inspector, the details pane underneath it. So if you look closely, we have that logic we built, that blueprint. It was actually a component, and we gave it some variables. The component itself was called character data. The blueprint is called character data. And when we click on it, we can see down here all of the different variables that we made public and visible and editable. In this case, favorite foods. It's an array of strings. So we click on it, we see, oh, favorite foods, and we see those default values too. We can add more strings if we want to. All right, we can get rid of strings if we want to as well. This allows us to create one blueprint, one component, but then slap that component onto a bunch of different actors, and we can customize what the favorite foods are of each different actor. Each actor can have different favorite foods, but they're all using the same character data component type. Okay? You can even add multiple character datas onto this one actor if you want to. So it's not just variables, though. Functions are maybe the big one, all right? If you look right above our little variables tab on the left side of your editor, you're going to see this category called functions. And I showed them to you during our previous kind of walkthrough, building out the stuff for Project 1. Right above the variables, right there, it's all about reusing your logic and making that spaghetti monster a little bit nicer, okay? If you click that little plus button up there, you're going to get to name your function. Give it a cool name. And so I create a function, let's call find all no-tie levers. Once I do this, I'm going to get this little starting node from which a line of execution can be drawn, a little white line, and we can add whatever logic behind that function that we want, which is kind of nice. You can customize this function's inputs and its outputs. If you click on the function, you'll see that you've got a bunch of stuff you can edit about it, and two of those things are input parameters and output parameters. Functions, often, they take arguments, which are those little nodes, those little slots, circles we see on the left, and they have outputs as well sometimes. So if we go in and say, I'm going to add a proximity float parameter, I'm going to add a location vector 3 parameter, right, that's why it's yellow, and a specific dish string parameter, now I can let the caller of my function, whoever is calling find all no-tie levers, can specify a lot more information to help us only get no-tie levers within a certain distance of a certain location with a certain dish that they like, okay? When we do this, it ends up looking like this. And in particular, this find all no-tie levers, we can go in and add an output. In this case, it is a set. It's blue, so we just happen to know it's of type actors. So now we have a very sensible function that makes a lot of sense, right? We find all the no-tie levers. Of course, we're going to return a set of actors. It needs to be a set because we don't want to have one actor in there twice. That doesn't make any sense, right? And we have some parameters that a caller of this function might want to specify to kind of tune their search for the no-tie levers, okay? All right, there you go. You've got a return node, and in order to complete the function, you have to return some actors into this little output node right here. So kind of cool. I have a challenge for you, and this is a little bit tricky, I think, unless you've got the ability to kind of either come up here and look closer, or maybe squint your eyes. Hopefully you don't have to do that, or watch on twitch.tv right in front of you. I want you to kind of look at how this function works, all right? And I want you to kind of explain it to me. Can you read this function and tell me what it's doing? Mm-hmm. I find it difficult, actually. I still find it kind of tricky to read these. It's just much slower than reading textual programming language. But you do get faster at it over time the more you do it. I simply haven't done it in about a year since we last ran this course. Can someone tell me what this is doing? How is it working? It's doing some really useful techniques here that you probably want to use in your Project 1. Can anyone walk me through it? High level, what's going on here? It's finding all the no-tie levers. How is it doing this? Any ideas? A reminder, you can always kind of roll your chair up here if things are kind of hard on your eyes to see. Yes?
It's taking all the actors.
Okay, that's a big thing, okay? Isn't this crazy? Everyone, look at this. We are using a crazy function called get all actors of class. Now, if you have some blueprints that are like chair blueprint, and you pop a bunch of chairs into your scene using that blueprint, well, you can use this function and say, my actor class is blueprint. You click that little checkbox there, and you scroll down to the chair blueprint. And it will give you a reference. It'll give you a list, an array of all the chairs in your scene currently. But you know what we did? We left it on the default actor class. What does this mean is going to happen? Which actors are we going to get? All of them. All of the actors, every single thing, every object, every invisible object in your map. Everything you see in your outliner view, you're going to get in this array. Okay, awesome. We are iterating through every actor in our entire map. Okay, we're iterating through them, and what are we doing to each actor? What are we doing? How do you know if an actor is a no-tie lover? Does anyone know? So we have this actor back here. This actor is called Chair, and it is a no-tie lover. How do I know this? Well, this actor could have no components. It could have one component. It could have two components, which it does. It could have 1,000 components. It could have components of any type, okay? But in particular, it has one component called character data, which happens to have a favorite foods list, a favorite foods array, an array of strings. One of those strings says no tie. Thus, if we want to know if an actor in our scene is a no-tie lover, we're going to look for all actors that have the character data component. And if they do, we're going to look in their favorite foods array to see if they have no tie in that array. Okay? That's the plan. Find the actors, grab their character data components, look through their favorite foods array. Doesn't it feel like we got like 3 for each loops going on, don't we? Okay, that's not quite how it ends up looking in the code, but we actually have 2 that are visible in the code, okay? So look at this right here. We grab all the actors. That's kind of our first for each loop, if you think about it. We then iterate through all of them. We grab that character data component off of the actor. Now, if it doesn't have one, then this is going to be null, and we won't iterate through the array. But we grab that character data component, which has a favorite foods string array, and we're going to iterate in a for each loop through that string array. And for every one of those strings, we're going to check if it's equivalent to the string equals if it's equivalent to the string no tie. Okay? If it is equivalent to the string no tie, then we're going to branch on that fact. True, they're the same. Good. We're going to add that current actor that we're iterating through to our result array, our result set, sorry, just to make sure we can't add them twice. After we're done going through every actor to check if they like no tie, we're going to come out this completed node, and we're going to return that result set that we've been building up during the function call. Whew. Dang, okay. Isn't this a lot? For something that's relatively simple, actually, it's quite a lot. And if this were textual code, it would be like a tiny little block with a couple nested for each loops, and that's it. Okay? But here, it's this gigantic, whole page thing. You have to squint to see it. All right? And what's nice about all of this is that this is a function. Remember, see? Find all no tie lovers on the left, and then the return node right here to return us that set of no tie lovers. So now we can write this much more simple code that runs every frame. What does this code do? What does it do? Can you imagine an exam in this course? If we had to have an exam. In my game engine architecture course, because it's an upper level CS course, we had to have an exam. In this course, it'd be like, man, here's some blueprints. Tell me what it does. Draw some blueprints. Write some code. Except you can't write textual code. You have to write me some nodes. How about that? I'd have to provide you with like 50 pages of blank space so you could write anything interesting. Okay. What's going on here? Yes?
Yes. Returns the string we got from function, or if the length is 0.
Well, there's no branch here. There's no branch. Okay, it's doing something with the length of the no tie lovers, i.e., find the no tie lovers using this function. By the way, if you have a function like this, quick tip, just double click on it and you'll dive into the function. You can see it. It's really nice. Every frame of our game, so boom, 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 60 times per second, we will come out here, grab all the no tie lovers that exist in our scene. And we're going to have that array of all the no tie lovers. We're going to check how long it is. We're going to append that number. So maybe we have 0 no tie lovers. Maybe we have 1 no tie lovers. Maybe we have 5 no tie lovers. We're going to append that to the front of no tie lovers exist. So let's say 5 no tie lovers exist, and we're going to print that. Okay? What is this doing? Every frame, we're simply printing how many no tie lovers are in our current scene. That's it. Okay? And this gets much, much nastier if you don't have this function. You have to add all this stuff onto that slop that you see up there. Ooh. All right, what's up?
Is the thing between length and append just like a conversion thing?
Yes.
Okay.
Yep. This is a conversion, and you can tell because over here we have this kind of cool blue. So I think this is like the integer blue or the teal. And over here we have the pink, which means string. I've just seen this slide enough to know that it's those types, right? But the types are color-coded in Unreal. It's kind of nice. And that's the conversion, right? Okay. How about comments, right? Comments are actually a very big part of programming, especially when you're programming on a team, and you know that your teammate is going to have to look at your nasty code and figure out what you were trying to do. Okay? Well, you can right-click and you can actually just start typing comment, and you'll find that there's a comment option. There's a comment node that you can make. And it's really cool, actually. Not only can you put a bit of text there, but you can actually have a big group in which you're able to put nodes into the comment and actually then move the comment around and keep related functionality together. So super, super cool. I mean, this almost feels like a soft function sometimes. But I highly recommend doing this often because it's very easy for you to write code one day, come back to it a few days later, and you don't know what you were even trying to do. Okay? So make sure you leave comments, especially as you're just getting rolling with Unreal Engine programming. At this stage, everything takes more brain power from you because it's so new and you're not used to reading code this way or writing it this way. Classes are the big thing. If you understand classes and what they mean in Unreal Engine, you will understand the engine and how to work within it. Okay? In Unreal, the most important thing to know is that blueprints are classes. Classes are blueprints. They use these interchangeably. They are synonyms. And they really do kind of mean the same thing. They have the same features. I'm not really sure why Unreal chose to just not use the word classes. A lot of programmers would be much less confused if they did so. But we have blueprints, we have classes. If you see code like this ever, you are looking inside. You're looking into the guts of some sort of class. Okay? After all, where else would we put functions and variables? In an object-oriented programming language, you only find those within a class. And blueprints, Unreal Engine is very object-oriented. Every time you create a new blueprint or blueprint component, okay, you are actually creating a new class with everything that entails. So, right, you can find your new classes, your new blueprint in the content drawer, right, at the bottom of the screen. In fact, I see two of them, okay? We have a blueprint component and a blueprint. What's the difference between a blueprint and a blueprint component? Anyone know? Should I open up Unreal? Can I get that going? Where is it? Here it is. Can I just open that up and just show you right now? No, don't update. We'll be here all day. Oh my gosh. Yeah, why not? Launch this. Is it available? 5.4. Does anyone know the difference between a blueprint and a blueprint component? Both of them are blueprints, but they are kind of very different. One of them is kind of Unity style programming, where it's just a bundle of logic that you attach to some other object, some other actor, or a blueprint is an actor itself. So once this is done loading, I will show this to you and I'll make it much more clear. Comment?
Oh, that's
Just going to answer it. Yeah. Hello. It's coming. Let's keep going and I'll show you in just a second. Okay? When you create a new blueprint, a new class, you can, let me see here, 5.4 current, why not? When you create a new type, a new class, a new blueprint, you can then reference that new type in other places. For instance, once you've created the Big Biscuit blueprint, which might just be like a biscuit you downloaded from Fab, and like now you're instantiating it all over the map. Now you can actually use it as a variable type. And that variable can only then be referenced to one of those biscuits that you have put out there. You can instantiate instances of that class like this. Let's say you create a blueprint, okay? You create a blueprint. I'm going to take this table, I'm going to click this button, and I have the option of creating a new blueprint called Table Blueprint, okay? Now that I've created this class, you're looking at it. You're looking at a blueprint class. This is now a new data type. You can create variables of type blueprint table or table blueprint. What I can also do is I can add logic onto the blueprint itself. And I can also then find the blueprint in my content drawer and I can drag it out to create new instances of that class, right? The whole point of designing a class in C++ or Java or C# or Python is that you can instantiate the class. You instantiate the class to create as many instances as you want, and then you do things with them. Here, it's the same thing. You had a table, you turned it into a blueprint. That's now a class. You're now instantiating that class by pulling it out, okay? This is a normal standard blueprint, but it is not a blueprint component, which is what I'm going to show you in just a bit. I recommend creating lots of blueprint components, but okay, you can use these really powerful functions to do a lot of the work you need to do on your Project 1, especially P1 Alpha, which is coming up soon, starting Wednesday. You can always use the node get all actors of class. So I could specify get all actors of class, and then I configure it. I only want table blueprint. And that will give me only the tables that you saw in the example a few moments ago. Once you have an actor, you can do this wonderful function, get components by class. Actors have components. Blueprints have components. I think we can even see it in this video if we go back to looking at the blueprint, right? Here we go. So this is a blueprint we are looking at. It's an actor. And actors and actor blueprints, they have components. This is the name of the actor, and everything in this list you see underneath it is a component. So how many components does it have? 1. It's called the static mesh component. It's a very powerful component that can do so many different things. It can do physics, it can do collisions, it can render your object. It does 1,000 different things. That's very not Unity-like. Unity prefers smaller, simpler components and more of them. But you can put more components under this object if you want to. You can give the table as many components as you want to. Those affordances that we created during our last lecture are components. So we can give this table as many of those affordance components as we want. Okay, and then you can grab those components if you need to. You can mess with those components using get components by class. It's very, very nice. Okay, yep, here we go, right? So I've got lots of actors here, all right? I've got this ball here. This ball, if you look at it, has 2 components on it. 1 and 2, the grab component and the static mesh component. These both are blueprints, but in particular, there's a certain kind of blueprint called a actor component. When I right-click in here and I go, I want to create blueprint, I love how they put blueprint class in here, like just to try and catch your eye in case you're confused about what a blueprint is. It's a class, okay? If I want to create an actor that I can just drag and drop out here, like the table, I would just choose actor. If I want to create a component that I can put onto other actors, then I would choose actor component, okay? And I can then, I can choose any class that I want if I want to derive from a custom class like the affordance class that we made. Hopefully this is making some sense. The important thing here, though, is that the find all no-tie lovers function uses actors and it uses components. It finds all the actors of a certain type, actor, i.e. it finds every actor that exists, no matter what kind of actor it is. And then it goes in and finds the components that have been associated with that actor. All of these things are classes. All of these things are blueprints. Okay? Pretty cool stuff. So if you look at what it's usually like to create a class in C++, like this is how you might create a class in C++. You have a human, and that human has a vector of interests. Now, interest is a data type we don't know much about, but it could be anything. We don't really care about it, though. It's just an interests array, because human beings have many different interests and hobbies and things that they resonate with. We have a float here within our human class called happiness. Just like if you're playing The Sims, happiness can go up, happiness goes down. Hunger goes up, hunger goes down. You can have functions like eat, sleep, and talk in this C++ class. And if you look at this blueprint, this class in Unreal Engine, it's the same thing. It's exactly the same. actually. These are mirror images of each other. The only thing that is different is that the UI is slightly different. That is it. Okay? There is the eat, sleep, talk function, just like it is here. We don't see the implementation of either of any of these functions, like the C++ ones, the Unreal ones. We don't see the implementation. But we see the variables. Happiness, interests is an array of interest data types, just like it is up here. And so it is the same. Okay, we can create this class really quickly in Unreal Engine. Let's go ahead and watch. Let's say that I want to have a human being class. Well, I'm going to go into my content drawer. I'm going to right click. I'm going to go to Blueprint class. I'm going to choose to make this a normal actor. Okay, which means I can drag and drop it and bring it out here into the map, just like the tables, right? This isn't a component. This is an actor. And so I'm going to name it human. I've now created a human class. When I go into it, it's an empty class. It has no visuals. It has no variables. It's got no nothing, all right? It does have a place where we can start putting logic and variables if we want to. Here, I've created an interests variable of type interests. There it is right there. It's a custom data type. And then I'm going to go ahead and turn it into an array so we can have multiple interests like a human does. I'm going to create my happiness float variable. I'm going to turn it into a single float data type. So there, it's a float data type. Oh, I think I forgot to make it into a single. It's, well, we have many happiness values, it seems. We're creating our eat, sleep, and talk functions. And there we go. The last thing I need to do is click compile. I don't remember if I do it here, but yeah. Cool, rock and roll. Good. So you can recreate the stuff that you would put in C++. You're just going to do it in a little bit of a different UI with some different things you need to click. The takeaway from all of this long tangent, is that blueprints are classes. Okay? They're pretty much the same thing. So you should think of them that way, and that will simplify how you program. All right? There are such a thing as data-only blueprints. Have you ever used a struct in C++? Okay, structs are kind of similar to classes, but they don't tend to put functions and data in proximity to each other. Usually a struct is just a couple variables that have been packed together. That's it. And so here too, you have something that is the analog of it. You have a blueprint class, but we haven't put any logic or code into this blueprint. Instead, you can see this blueprint, which is actually your VR game mode, which you've seen a few times, is only a bunch of variables. And you can swap those variables out. They have particular variable types. You know, it's all just very familiar. And you can open it up in the full blueprint editor if you want to add logic to it later. There's a little link you get for that. So when you have classes, you are bound to have ways to reuse those classes. And so we have inheritance as well. If you ever open up a blueprint, whether it is a component or an actor or something else, you can look in the top right corner and it's going to have a parent class. It is definitely going to have a parent class. Inheritance is a huge deal in Unreal Engine in a way that it's not quite as big of a deal in Unity. All right? In Unreal Engine, whenever you create a new class, you're bound to be deriving from something. And the class that you choose to derive from, and you must choose, is going to make a big difference as to what your new blueprint can actually do. Okay? For instance, if we derive our blueprint, if we derive our class from actor component, we can't drag it out into the scene like we did those big tables. But we can drag it onto other actors, like our affordances, like the user data component I showed you a few slides ago, okay? Like in other languages, public variables and functions will exist in the derived class. You can override functions in the child class if they existed on the parent class. This is called polymorphism, and it is one of the most powerful things in programming. Very elegant, It is what we did in Project 1 during our demonstration. We created an affordance parent class, but actually most of our work is creating child classes that derive from that parent to get the nice, juicy interact function. That interact function is where all the magic happens. Every affordance is guaranteed to have one, so we can use polymorphism to grab all the components, regardless of what child type they are, and just call interact on all of them, and all their unique interact functions get to run, which is really, really fantastic. So you can override these functions really simply by just going down to your Functions tab. It's a little bit small, and you see this little Override tab. You click on it, you choose which function you want to override from the parent, and you just do it. Okay, not too bad. So in C++, inheritance tends to look something like this. You might have a human class up here with all the things that we've already gone through, but maybe you have a professor class, which is a human, except it introduces a new function called teach. It has all of this stuff as well, but it also introduces a new function called teach. Maybe you have a student class that derives from human, just like the professor does. But the student class actually doesn't introduce anything new, but it takes the eat function, and it takes the sleep function, and it overrides them. Because students eat a lot and they don't sleep very much, okay, compared to normal humans. So, right, if you want to derive from human in Unreal Engine, here's how you do it. Imagine we've created a human class, which we did. You can see it right down there. We did it just a few moments ago, okay? Right there it is. But we want to have a professor class or a student class. I'm going to go to create a new class, and in this menu we have a lot of common classes to derive from. But down here, under all classes, we will find that human class, right? There's human, click it, go. And we have our student class that derives from human. You can check this, make sure that everything went well. When you open up the student blueprint, up in the right corner, top right corner, you can find parent class human. And if you go look at the functions and variables, you can go to override and you see, look at that sleep function, talk function, eat function. They're all there, and we can change them if we want to. If we don't override them, then they'll work the same way as they do in the parent class. But if we do go and override them, then we can go add some additional logic, like, hey, let's set our happiness value to something really, really big. Because when students eat, they get uniquely happy compared to a normal human. Notice that that happiness value from the parent is here as well. So you can see it's just the UI that's strange, okay? This is all exactly what you would expect. Polymorphism, I talked about it a little bit. If you don't know what it is, here's kind of the classic example, I think from Wikipedia. No, askpython.com. The idea here is that if you've got shapes, you want to draw them. But you don't know how to draw a shape, because if you say the word shape, it's like we don't know what the shape is. It could be any kind of shape. It could be a circle, could be a rectangle, could be anything. But we have a child class that derives from shape and gets the draw function. But we can override the draw function to change what it does and how it works. The rectangle can do the same thing. The square can do the same thing. It's very confusing to me that these are two different child classes, because like a square is a rectangle. So we could just have a circle and a rectangle class. That'd be pretty cool, I think. We could have like a general polygon class. But in any case, if we want to call the draw function, imagine we have like 5 circles and we have 10 rectangles and 15 squares. We have all of them in a list, an array, but how can we have all of them in an array? They're different types. We can't do that, can we? Can we? We can. Even though these are of different types, different classes, because they all derive from shape, we can have a list of type shape or an array of type shape, and these can all be in there. Okay? That is polymorphism. And because we know that they all derive from shape, we know that they all have the draw function, which means we can iterate through them and call that draw function. That is polymorphism. You are taking a bunch of very different things and you are treating them all the same. Okay? I think that's literally what polymorphism means. Like the old ancient Greek word. Use a base class type shape to reference a bunch of unique derived classes in a standardized, elegant way. Very, very powerful stuff. And that's what we're using for our affordance and selection architecture in Project One. So hopefully you'll get a feel for it and why it's so useful as you continue to work on Project One and do more programming and use more interact functions. I've got a quick tip for Project One. You're going to use those interact functions a lot, but you don't need to use them on everything, okay? You can use event tick. You can use event begin play. And for some features, you're going to want to, okay? So the interact function isn't where you put everything. Okay, so what I want to do is I want to take 5 minutes, then we're going to come back. We're going to talk a little bit about Unreal Engine debugging, and then we're going to talk a little bit about materials, what they are and what their point is in Unreal Engine. And it's kind of important because on P1 Alpha, you're going to have to start messing with some materials to get certain things to look good and to move and change and stuff. So I'm going to turn the audio, the music on, and I will see you in 5 minutes. See you then. Okay, so I've got a question. When it comes to debugging, there is a kind of endless list of powerful tools out there. However, how many of you just tend to do this? You go cout, you start printing messages, you start printing variables, you run the program, you see what happens, right? This is your main method of debugging. Okay, I'm not particularly ashamed to admit that this is how I often debug, because often when I have a bug, it's kind of a small one, right? And it can be very quickly cleared up by just kind of learning a little bit of state. However, often you want to learn a little bit more about what is happening in your program, okay? This is a true classic, and you can do this too in Unreal Engine. I encourage you to if you just want a little bit of quick information. Often, one issue I see a lot is that students are writing code, but it's not running. Like they forget to bring the white line there, right? So it will never, ever run. One really good way to see if that's a problem is to simply put a print string statement there with some sort of interesting string to let you know that you're actually getting to that point of execution. You can pair this with the make literal string node and the append node if you want to, in order to kind of debug values and make it not look so crappy. Okay? It kind of looks like this, but my goodness, this is a lot of stuff, right, for just one variable being printed. It's part of the reason that I'm not a huge fan of visual programming. Of course, I know textual programming, so I don't really need to use visual programming. But you'll get something like this, health 0.0. It'll be in the top left corner of your screen. It can be hard to see this if you are in a headset. So often, you will want to put the headset on, get to where you need to be, and then take it off as you're triggering the message so you can actually see if it's there, or ask a friend to verify it's there if you need to. You can also, later on, search through your output log, which is right next to your content drawer on the bottom of the screen, and you should be able to filter for any messages that you might want to find or check later. That's a good way of doing it as well. This is a really, really kind of nice way to visualize your control flow and what's happening. If you don't have print statements, if you want to go beyond print statements, here's what you can do. You can go up and play your game, but you play it from your blueprint, okay? You don't go back to the visual editor. You stay looking at your blueprint and you press that green button. You should be able to keep your blueprint up. And if you select a particular object right over here in the corner, okay, say hi in table. So the table object, right, it's called say hi because say hi is the component in the table object. That is the actor, the table. You can now see, as you play the game, you can see how control flow is flowing through that component. You can see what branches it's going down if you have branches. You can see variable states. You can do a more advanced form of debugging this way if you want to. You do need to specify an object or an actor because you might have many actors. Which one do you want to check on? That actor might have many components. Which one do you want to look at? Okay, so you can see the table object, the table actor, right, and the say hi component on the table actor. Breakpoints are a thing. Watch variables. All these features you might be used to from other debuggers on other platforms, like maybe Visual Studio or GDB, are there as well. So we have a component on the Cube 3 actor. Cube 3 is the actor. The component on it is called Show Debugging Stuff. I'm going to right-click on it, and I'm going to go to Edit Show Debugging Stuff. This will open up the guts of that component. We can see the event graph. And we go to event begin play. We have a variable called special number. It gets set, we delay, it gets set again, we print it, we set it a third time, and we print it one more time. So if we want to kind of debug this at all, we can right-click on one of these nodes and we can go to Add Breakpoint. We'll see this red dot be kind of added to it, just like you tend to see that little red stop sign on your a line of code, right, in a visual editor. We can go in here, and I think I right-clicked on special number, the special number variable, and we select watch this variable. This means we're going to get to watch the value of the variable as we run the code. We can now run the game, start simulating it in this case. Notice, this is actually a really valuable thing. Notice this little icon down here below the green button. This is simulating the game, not playing it. You are very used to clicking the ... button at the top and going to VR preview, right? But there's actually ... and you can click on simulate instead. That will run the Unreal Engine project, but it will keep it in this kind of viewable editor pane. So you can actually fly around like normal and you can kind of watch things happen. If you have any enemy AI, then you might be able to watch the AI walk around and do its thing. If you have objects, physics objects, you can watch them fall, right? Stuff like that. So we're going to simulate the game. We go back to our show debugging stuff component. We're looking in the guts, and it stopped. We hit the breakpoint, okay? So the game has been paused. We need to click this green button to make it run again. And we can also see that our special number variable that we've right-clicked and set to be watched will now tell us exactly what that number is. So, as you might expect, we can click these buttons up here, very familiar buttons, to step through from function to function to function and kind of watch as things happen. We can see that special number coming in. It's 2. Oh, no, this is what we're setting it to. You can go to Debug, Blueprint Debugger, and you can actually look at all of your variables in here and know their current state just instantly. And so the main takeaway here, you don't need to use these, and you don't need to remember exactly where they are, but the important thing is that you remember they exist. And when you have a big problem, when you don't quite understand what's happening in your blueprint, and I guarantee, especially next week on P1 Alpha, there are going to be moments when you're very confused about why is this happening in my blueprint? What is happening in my blueprint? That's when these tools are really going to kind of come to life and help you out. If you're having these really strange errors with Unreal Engine, there's a non-zero chance it is flat out a Unreal Engine bug. The Unreal Engine editor is constantly introducing new fun bugs, and sometimes you just want to Control-Shift-Save everything, okay? Make a commit in your, version control, and then kill it and reopen it and see what happens, okay? All right, I think the last couple things that I will tell you about Unreal, this is a pretty important one. Context-sensitive search. All right, when you right-click in the middle of your blueprint, when you're scripting, you right-click, there's this little context-sensitive search right here. And when you search, you'll find certain nodes. It happens that Unreal, by default, will tailor the results that you see in search based on where you are searching. So if you're in a component like isCurtain, you will get options in your search menu that you might not otherwise get. So set physics linear velocity. Look, it doesn't even exist in here. Set physics linear velocity doesn't exist. Why? Because we're in a component and it doesn't make sense for it to exist. It doesn't have any velocity. It doesn't have a position, okay? So this just flat out doesn't exist. But if I uncheck context sensitive, suddenly I will see the function that I want right here. And I can bring it out, all right? So it also depends. Have you ever seen, let me see, can I show you something? Let's go into VR Pawn real quick. There it is. I want to show you some code. Hopefully it'll open up relatively quickly. Okay, here's some code, right? Imagine that you have an actor. Like, here's an actor. Hand left. It's an actor I'm pulling out. If I right-click and start searching for things right now, you know, I might find what I want, I might not. But actually, I can give Unreal a huge hint by dragging the thing I want to act on. Drag it, node, and then drop it. And now it will give me all of the functions that are specifically tailored to this thing right here, this hand left actor that I am telling Unreal that I want to use. So I encourage you to make use of that property when you can. You'll get better suggestions that way. But if you can't find something, you might need to uncheck that box. So yep, drag a node and the result will change to be nodes that use that particular data type. You can uncheck the context-sensitive checkbox to just freely search through everything that's available regardless of context. And sometimes you're going to have to do that because the function you want will literally be hidden from you because Unreal thinks you're going to use it with something that you're not going to. Okay? So you uncheck that box and you find the thing. Sometimes different nodes have the same name. So please check the input and output params very carefully. I know this tends to bite students a little bit in Project 1. You will have a particular node, but you also have a particular data type that you have to use it with. Unfortunately, you'll right-click and you'll find the version that uses the wrong input. You won't be able to plug it in. It's the correct node. It looks like the correct node. It has the right name, but the inputs are wrong. Well, what is that called in C++ when you have three functions with the same name, but they have different arguments, different input arguments? What's it called?
Overloading.
Yeah, it's called function overloading, okay? Or argument overloading. So that happens in Unreal Engine 2, and it can be very confusing because it looks like the right node, but just doesn't take my thing, right? The input just won't hook up, and that's usually why, okay? Okay, a few quick miscellaneous notes. Unreal Engine source code. For those of you who want to be very hardcore about this, who want to dive into the source code, did you know that Unreal Engine is open source? It is not public domain, okay? It's not public domain, it's open source, which means you can read the source code. You can't use it for anything you want to, though, okay? At least not without getting a license from Epic Games. You can watch some videos here. This is kind of an incomplete part of the lecture. It's not very important for us. But you can go in, jump through some hoops, and you can actually get added to the GitHub for Unreal Engine. And you can build it from scratch if you want to. You can go under the hood. You can find out how it works, load it up in Visual Studio or something like that. There's an entire wiki page on building Unreal Engine from source and how to do that. My assumption is it would take all day because it is a huge engine, but could be kind of interesting for you, okay? I have some tips in here if you decide to use Unreal C++. This is what a class looks like if you are making a new actor blueprint in Unreal C++. It is a bit of a mess, okay? You have macros like uClass and generated body. And you can't forget these macros. These are the macros that the preprocessor is going to come through, and it's going to kind of set up reflection for your C++ types. It's going to set up automatic memory management for them. It's going to do a lot of things to hook everything up. C++ by default does not support reflection, and so it can be very hard to do this otherwise. But Anyway, Visual Studio will complain and tell you that none of this works, but then it will all work just fine. You can do a patch build by using Control-Alt-F11 when you're editing this stuff, and it will take your changes in C++, it will build it and patch it while the Unreal Editor is running. It takes about 10 seconds. It's not as fast as compiling a blueprint, but it's faster than restarting the whole engine. Yes, again, you don't use the standard C++ data types like vector. If you attach a capital U or capital A as a prefix to your file names, Unreal is going to make assumptions about what these file types are. And the build process is going to go crazy if you don't have them in very specific formats, okay? I don't think I'm going to really tell you anything more. If you go into Unreal C++, the AI assistants are surprisingly good at remembering all of these caveats and nuances that will blow you up if you don't know about them or you haven't studied them enough to remember them. So that's my tip. If you do go exploring Unreal C++, take GPT with you or Gemini or Claude with you and be ready for some weird shenanigans. But at the end of the day, if you're making a hardcore, real deal, AAA, big time, big budget game, very good chance that you are writing Unreal C++ code a lot of the time, okay? With kind of 50-50 blueprints and Unreal. You write Unreal Engine C++ code so that you have new blueprints that you can use as a game designer, okay? I think what I want to do is I want to save our talk on materials for next time, okay? So I'm going to be walking around. A bunch of you are already on to Project 1. Please let me know if you want any additional office hours. We've got 15 minutes for that. And then I'm going to have more office hours from 6 to 8 p.m. tonight. And does anyone have any questions about anything? Yes?
Are we able to convert existing blueprints into code and vice versa?
I think you should be able to, but I don't know if it's true. I've heard that it's very common for engineers to write out a prototype in blueprints, get it working, and then move it to C++ once they're confident the system works the way they need it to. I would strongly suspect that there's some tools that can auto-convert for you. But I think when you're going into C++, one of the reasons you do so is to get the power to kind of really manage memory and be more efficient. And so I feel like actually it might not make sense to auto-convert a blueprint because the auto-converted stuff might not be very efficient. It might not know what kind of choices you want to make when you're doing that conversion. I don't know. I imagine it's possible, and there are probably tools for it. But Unreal is not my main engine, and so I don't do that much. So Unity is my main engine, and Godot is coming in as the main number 2 for me these days. Mainly because we're going to use Godot as our primary game engine for the upcoming MMO course. Okay, EECS 498 Live Ops and MMO architecture. Really, really fun. It's going to be Godot 4, which means C# as the programming language, as the client. And then we're going to use C++ and Google protobufs on the backend server side, along with Docker and AWS for the deployment and cloud infrastructure stuff, sharding and stuff like that. So it's a very, very interesting challenge. Ask me about it sometime because we have to figure out how to auto-grade this. We have to figure out how to auto-grade all of this. Auto-grade the client, auto-grade the server, and auto-grade the cloud infrastructure you set up. How on earth are we going to auto-grade all of that? Well, we have some ideas. I think maybe the client won't be possible to auto-grade. We'll have to grade that by hand. But the back end of the cloud will be. And so, yeah, might be kind of interesting. We'll have to see how it goes. Okay. Anyway, I'm going to be walking around. We got 10 minutes or so. Please raise your hand if you've got any issues, and then I will see you later tonight for our 2-hour office-hour block from 6 to 8 p.m. See you all on Wednesday for our first film. It's going to be The Matrix. It should be a really, really good time. It is a really fantastic film, in my opinion, very entertaining, but it's also the kind of film that has a lot of really interesting ideas. And the more you watch the film, the more interesting those ideas become and the more apparent they become. Okay, see you next time, everyone. Bye-bye. All right, everyone online, we will see you later. Thank you for joining us. Take care.